Hello, and welcome to today's daily Leetcode challenge. We'll be going over question 746, min cost to climb Ming stairs. I'll be going through my thought process as I come up with a solution, then stick around for the end of the video where I compare my solution to the solution of others. Cool. With that, let's begin the question. So I'm given an array cost where cost at index I is the cost of ith step on the staircase. Once you pay the cost, you can either climb 1 or 2 steps. So if this was like a ladder, I could either jump 1 or 2. Okay, sounds good. I can either start at index 1 or 0, 0 or 1, return the minimum cost to reach the top of the floor. Okay, so basically, why is this problem difficult or tricky? It's not really tricky, but you have to understand that going over all of the possible variations of which you can climb a step is tedious, and frankly, it's going to be impossible because you can run into these local minimums. You could jump the first step, but then that would prevent you from figuring out, well, what would have happened if you were to jump the second step first, or to the second step. And so choosing between the minimum of these two, choosing between the minimum of the next step and the second to next step is not the correct approach, because you will run into this local minimum where, let's say in this case, right, you have this 10, you could have taken that, but that would have prevented you from eventually going and seeing, hey, you could have taken 15, which would have essentially gotten you over to the final floor anyway. So what are the different choices here? We could have, let's illustrate this. Let me illustrate this here. We have 3 steps, 1, 2, 3, and this step is of cost 10, this is of cost 15, and this is of cost 20. Now I'm at this floor right here, or I could start at this floor, but the point is, I could have either taken 1, 2, 3 steps, in which case I would have accumulated 45 points. I could have gone with a 1, 2 step, in which case I would have accumulated 25 points, so the 10 and the 5. I could have started with the 15 and then jumped, right away to the final step, which would have been 15. So yeah, 15 here, like obviously this is simple, is the best choice here. But how do I know how do I know from this or from this position, what is the cost that it would take me? What is the minimum cost that it would take me to get to the last step? Well, in here, first of all, this is a dynamic programming approach, 100%. You are building up your cost from step from the back, because the only real information that you know in the beginning is that it takes you 0 cost to be at the last step. Then if you were to start at the, let's call this first, second, third. If you were to start at the 3rd step, you would know that it would be the cost of the step itself, plus whatever additional steps you would have to make to get to the final floor. In this case, it would be 0. So, I mean, no confusion there. This is just going to be 20. It would take you 20 points. It would cost you 20 to get from the last step to the final floor. Well, what would be that same question for a step that is for number 2? Well, for number 2, it would really just be the for number 2, it would be the minimum. It would be this 100%. So because it takes us 15 points to jump from step 2 to anywhere else, but then it would also be the minimum of these two elements here, which is 0. So so this is 15. And if we were to do this for the same 10 here, it would obviously be 10 right away, but plus whatever is the minimum of these two, so 15. So the minimum here, I mean the value here would be 10 plus 15, 25. And I mean, I hope that the pattern here is recognized. We're always, to populate this DP array, you are always adding the value that it takes from the cost of the step plus the minimum of the next two steps until obviously you get to the last element, right? So for example, if I'm calculating what is the step for this guy here, it would be 10 plus whatever is here. And so this kind of gives you insight into why I have to pre-populate the array from the back. Hopefully that explained it well, but this is the implementation. Here we have the DP array. We're going to say that it is of length cost plus 1. I want that extra number on the last element representing the final floor. And then I'm just going to enumerate reversed actually, one second. I'm going to just do reversed range of cost. Let's see that I is being printed correctly. What I want I to be is all the elements, all the indices of cost in reversed order. So in this case, it would be 2, 1, 0. Let's see, the list cannot be. Am I doing something wrong? Range. List object can be interpreted as a list. Do I have to do this? Sorry, it's just little tiny bits. What am I doing wrong here? For I in oh, len cost reversed. Sorry. There we go. So I was passing a list to range, but I really just wanted the number. Cool. So now that I have this, let's say the cost of the step is just going to be cost of I step. And this cost step is this value right here. And then we are going to say that dp at I is equal to cost step plus the minimum of these two values, of the next two values, which would just be dp of I plus 1. And what is that? I plus 1, and then also the minimum of I plus 3. I plus 3 because the end of the slice is always exclusive. And the reason why minimum is because this is the easiest way to tell that if we're somewhere here, then get the end of the array here. So that would just be minimum of I plus 3 and len of dp plus 1. And for sake of cleanliness, let's just do this. Let's print dp to see that we are getting this correctly. And for the test, I want to make sure that I'm getting 25, 15, and 20. 25, 15, and 20. Perfect. Then simply return the minimum of cost of dp from 0 to 2. Awesome. Guys, so this is a simple problem, but it employs a difficult concept, right? So without knowing that this would be a dynamic programming, a DP solution, you would have a hard time figuring out how to do this. Let's look at some of the faster ways they did this here. And I mean, breaking it down, this is pretty much the same thing that we're doing. This is one-to-one to what we're doing. They might have some optimizations with regards to like how many operations you're doing because they're not looking from the first element, but ultimately all of these solutions are doing the same thing. They have a dynamic programming array, DP array, and they're looking for they're looking to find the minimum of the first two elements. So yeah, I mean, hopefully this visual kind of made it clear. Overall, dynamic programming gets used everywhere, and these are the cases where it does. Building your solution up from the case that you know for sure, which is our last step. Cool. Let's keep this short. I hope this helps. See you later. Bye.